This is not the internet. This is the metaverse. Hello pioneers. This week I'm going to take a look at something very important, and that's this human-in-the-loop training of AI models. Now, let's go across this stuff again. We know we have the Pi Network DePIN cloud. All right, that's providing the infrastructure for OpenMind to train their robotics and all their models. Okay, we know this. And they're also going to be providing the human element, right? And this is for human-in-the-loop training of these models. Okay, so we know all this already. Now, where did we first hear about human-in-the-loop? Okay, this is from the blog post, Pi for AI, okay? And in here we saw this human-in-the-loop first mentioned. Now, in this blog post they also talked about Mechanical Turk. Okay, so if you look at Mechanical Turk, this is from Amazon. Okay, this is where human-in-the-loop training can occur. And this goes back to the mid-2000s. And who was the very first, well not the very first, but the number one customer of this platform? Well, it was Fei Li. Okay, she did a lot of image processing using ImageNet, and yeah, they were the number one users of this platform. And over the years, like it started in 2006, you can see in 2017 that 95% of images were getting correctly identified. Okay, so massive amount of progress there. Now we've moved on a lot since then, and so you can imagine where we are right now. Now another example of this human-in-the-loop type systems is a thing called Rent-A-Human. And this is where AI agents, obviously they don't have any contact with the real world, so they actually need us meatbags to actually go out and do tasks for them. And so people sign up here, and AI agents negotiate and put out tasks for people to do in the real world. Right? So that's an interesting thing as well. Another example is OpenMind themselves. Okay, prior to their TGE, they had us mapping out our locations. Okay, so walking around with our phones, we could earn points, and this helped people get tokens when they went and did their TGE. So yeah, lots of examples here that you can do things. Now, obviously, us pioneers, we're going to be the first people on the Pi network to be able to provide this human-in-the-loop training for these AI models. Now, the things we're going to be doing is refining outputs, defining quality, verifying correctness, resolving ambiguity, and actually making sure that these things are actually useful to people. Now, some additional qualities that Pi Network provides is scale. Okay, so they need a lot of human input, not just a few people. Now, obviously, we have 60 million people on the network, so once we all get our KYC and all that, that's a huge pool of people that can participate in this human-in-the-loop training. Authenticity, okay, this is one thing they keep on talking about with the KYC and zero knowledge proofs and everything. Okay, got to make sure that that's the real people that are actually in this loop. And the cost, okay, so this is very expensive to set up, but Pi obviously has all this already. Okay, we have all the infrastructure with the blockchain. What is it, over 400,000 nodes. Okay, so that's a huge amount of infrastructure. Pioneers review training data. Okay, so this is one of the things that we're going to be doing. Okay, so correcting mistakes, approve or reject behavior simulations, give real-time feedback. Right, and in this purpose, right, what we act like is quality controllers, okay, and social coaches and ethical filters. Now, ethical filters is one that I really want to focus on, because what I'm going to show you next in this next section is primarily dealing with this ethical values. How to teach robots ethics. Okay, now this is a huge subject because there's a lot of different factors that come into this. You know, when you got human in the loop, you know, people's age, their ethnicity, what country they come from, you know, many, male or female, or, you know, whatever. You know, there's so many factors that govern people's ethics, right? And they differ for everyone, okay? So what we need is a collective training model, right, that can handle all these different scenarios and try to get different perspectives on everything, okay? Now, at the moment, I know everyone, you know, we've got the launch of CD games, so everyone's focused on that. Now, for me, I don't really care about that too much. You know, the game looks great and all that, but yeah, I won't be participating in it. But the thing that I like is this one that is a couple of doors down, right? And, you know, that's because it's talking about situational decisions, advanced ethical modeling layer, okay? So I'm going to take you all through this and show you how this is doing the exact thing that we would want to do in the human in the loop training. Now this application is called Resonant, okay? Human Decision Intelligence. And if we take a look at it, Resonant is a human decision intelligence engine for AI agents, okay? Fits the description perfectly for exactly what we want in the ecosystem for doing all the OpenMind training, okay? Now, I've researched all this. I haven't found any affiliation with the core team or whether they've invested into this or anything. But this is very professionally done, and when I show you all this, what's inside, you'll see that it fits perfectly into what we would require, okay? So it could be a private thing, I don't know. I messaged the guys in Telegram. I did see he saw my message, but I haven't heard back from him yet. And you know, maybe by the end of this video, I'll have some more information that I can add in. But let's take a look at it, okay? So this is it, you know, very nice website, great colors and everything. And if you want to go to it, okay, you go through the Pi browser. You can type in the URL, or you can just click from it from the App Store, okay? And sign in, okay? It's going to ask for the your Pi credentials, okay? So we'll do that, okay? Allow. Off it goes, and we get inside, and all done, okay? So now we're inside, okay? Very simple, and obviously it's just using the Pi SDK, and logs you straight in. Now, after you do a few control questions, it jumps you straight into the program, and what it's doing here, it's, like I said, it's doing all these ethical questions, but it's doing it on a very limited answer query, and really restricting your train of thought, if you like, okay? So it's a very, very tight controlled questionnaire. And that's just to get that nuance out, okay? So we can get a lot better quality of training on ethics, okay? So they do this thing with would you rather, okay? So it gives you two options, and basically most of the time neither of these options are good, okay? So you got to try and pick, you know, the best one out of the two, okay? So there's two of these types of questionnaires, okay? So there's the would you rather, okay, which is the advanced ethical modeling layer, okay? And then there's another one with it presents the classical trolley problems that talk about, okay? Now, this is where it gets really bad. So this is the case of like, you know, you have a train going down the tracks, it splits into two tracks. On one side of the tracks is your whole family, on the other side of the tracks is your wife, okay? Now, which one would you let the train go down if you had the choice, okay? So lots of things that you would come into question that would never happen in reality, but it gets that ethical mind going. Okay, so very interesting questions about this training. Okay, so this is how it works. Okay, so you go in, you pick your choice, and then you get rewarded with 1 point. Okay, so every now and then, there's 120 questions to start with, and every now and then, like I think it's like every 25 or so, you got to do this little thing just to test that you're human again. Okay, so you get rid of these little objects. Okay, and then you're back into the quiz. Okay, so once the quiz is completed, okay, you're all done. You've done the 120 questions, and you get all your points. Okay, all done. Now, once that's completed, you could go into the other one. Okay, so you go into this one, same deal, do all your choices again, and this time though you're getting 3 points. Okay, so you get rewarded more, because I think these sort of take a bit more time. Now on the website there's 3 Medium articles that they've published, so if you want to take a look you can get the links from there. The first one is the Agentic economy will learn how humans decide. Next is what is a decision-based LLM memory card. And the last one is Asimov's 3 laws won't govern AI. Okay, so we're going to take a look at these individually, and I'll just take out the points that describe things a bit more better. So the first one, the agentic economy will learn how humans decide. Okay, so if an agent is to act on your behalf, it must have some model of how you choose under uncertainty, how you weigh short-term versus long-term outcomes, how you respond to risk, authority, moral tension, or social pressure. Okay, so this is how I'm saying that all this ethics and all this type of thing, this is very hard for agents and robots to learn, right? But they need to know this stuff. So yeah, that's very self-explanatory. In an agentic economy, the most valuable signal is not opinion, it is revealed preferences under constraint. Okay, so this is what I'm saying now, they really constrain your choices in these ethical questions. Resonant starts from a simple premise. Instead of asking people to label themselves, ask them to choose. Each interaction presents a small forced decision between competing values. There's no scoring, there's no right answer, and no incentive to perform. Over time, these decisions accumulate into positions along independent decision dimensions that reflect how an individual navigates uncertainty, time, autonomy, social alignment, moral conflict, and information itself. Okay, so when you go through the quiz, you'll see how very diverse it is, and very tight in its questioning, but it covers a lot of different scenarios, right? So it's a great way to train these models. Now, once you've completed all the questions, if you go down to the bottom, okay, you can see that they've got a thing here called your pattern guess. Okay, so if you just click the down arrow on this, it'll give you a nice little profile of sort of what it's building at the moment. And this is just a profile on how you would react in certain situations, and what you think your ethical choices would be. Okay, so you can see how this training really starts to build up. Now, you can also see these graphs, and this is the whole collective. Okay, so this is everyone. I think it's about 4,500 people participating at the moment in this, so quite a lot of people, and yeah, you get a lot of insight into how people would react ethically, what ways they're leaning towards and all this, and this is all used to train the agents and the robots, and how they can interact in the real world, because let's face it, we know this is going to be happening, right? And we don't need the rules to be clear cut. There needs to be nuance and thought put into actions that they do in the real world. What is a decision-based LLM memory card? Okay, so from the website, this is the representation they give you. Okay, now it's not a physical card, it's just a virtual card, but What this is doing is compartmentalizing all the ethics questions that you do, because agents have different scenarios where different ethics will be used to help them make decisions. Okay, so it's not just one cut and dry overall reaching ethics paradigm. So an LLM memory card is a structured profile that can be shared with an AI to provide context about the user. Rather than relying on hidden behavioral tracking or long chat histories, a memory card provides explicit information that helps an AI align its responses with an individual. Okay, so we all hear about this misalignment all the time. So it's compartmentalizing everything so that it aligns for the particular task at hand. There can be many types of memory cards. Some may describe professional expertise, personal goals, knowledge domains, or communication preferences. Others may capture project context or long-term objectives. Memory cards are best understood as portable context layers that can be attached to AI interactions when needed. If prompts tell AI what we want in a particular moment, a memory card helps AI understand the kind of decision maker that we are. Okay. Now, examples that we're talking about is, if you have an agent for trading, okay, then you can use a certain memory card that tells that, what type of trader you are and what your preferences are. Do you like to have more risk, or do you like to play it more safe, right? So you can compartmentalize all these ethics and values that you have, so the agent can fully represent you better. Okay, very great system. I think this is really, really cool. Now we get into Asimov's 3 laws. Okay, Asimov's 3 laws won't govern AI. So this is the argument against them. 3 laws: a robot may not harm a human being. A robot must obey orders given by human beings. A robot must protect its own existence. Okay, now I think that means that as long as it doesn't contravene the first 2 laws. In practice, it reflects a model of decision making that diverges sharply from how humans actually think and act. Okay, so I think a lot of people have said over the time that these laws, while they seem good on the surface, over time and when you get the nuance and the context involved, they don't really work. So a robot may not harm a human being. The central issue is that laws assume ethics can be reduced to a fixed ordering of rules. Human decision making does not operate this way. It is contextual, fluid, and often internally conflicted. Even the concept of harm is unstable. A surgeon causes harm to heal. A regulator restricts to protect, and a parent withholds to teach. The first law becomes ambiguous the moment it encounters real-world nuance, where harm is not binary, but a trade-off shaped by intent, outcome, and perspective. Okay, so that's a great example there that, sometimes we're causing harm to make things better, right? But in the context of it all, you're not causing harm, it just seems that way. A robot must obey orders given by human beings. The second law, which prioritizes obedience, further exposes this gap. Obedience presumes legitimacy, yet humans constantly negotiate authority. Acts like a civil disobedience or whistleblowing violate obedience, but are often considered ethically necessary. A system that blindly follows instructions is not aligned with human norms. It lacks the capacity to interpret when a command should be resisted. Okay? So this just comes down to things like common sense, ethics, and all that. Okay, so again, we're showing that these laws are too simplistic and that a lot more needs to be done in training models to behave better. And the third law, a robot must protect its own existence. Similarly, the third law's framing of self-preservation as a lower priority rule fails to reflect how humans dynamically re-weight priorities. People regularly take risks, sometimes irrationally and sometimes heroically, based on values that cannot be reduced to a fixed hierarchy. There's also a structural limitation in assuming safety comes from restricting actions. In many cases, safety depends on understanding context. Refusing to act can cause harm, just as acting without interpretation can amplify it. The absence of contextual judgment is not neutral in itself, a decision with consequences. Okay, so we know this ourselves, don't we, in real life? You know, you judge every situation to itself, and you're always trying to not cause harm and produce the best outcome for other people, aren't you? Okay, so this is where all these trainings, you know, they just amplify everything that all the agents and the robots are going to require in the real world. And to sum all that up, Asimov's framework remains influential because it is elegant and intuitive, but it simplifies away the very complexity that defines human decision making. Aligning AI with humans requires more than encoding rules. It requires systems that can interpret and adapt to human decision patterns, recognizing that preferences are dynamic, sometimes inconsistent, and often contested. Okay, so that's just a little summary of, you know, while the rules seem like they're, you know, well-intentioned and very simplistic and they can handle everything, in actuality and in the real world, they don't work. Okay, so they're just not conducive to real-world actions. Okay, so that's Resonant. You know, I think it fits in perfectly with this human-in-the-loop conversation that I've been having over my past videos. You know, showing you how all the training models, you know, they're going to have all these requirements, and, you know, how us pioneers are going to be very, very active in helping train all these models. And Resonant is the perfect platform for doing that. Now, having said that, like I said, I don't know if they've got any affiliation with Core Team. I don't know if they've received any investment or anything like that. I haven't heard anything back on the Telegram group. But, you know, that was a little sneaky app that I thought was in there, and I think that's way more important than another game platform. As you've seen on Twitter, I have been putting out some reference codes, you know, so, you know, when you sign up, you can use those codes. Unfortunately, they're only a one-shot. Okay, so whoever gets in first gets to use it, and once it's used, I publish another code. At the moment, the app's been up and down, and I can't generate a new code yet, so yeah, I mean, it's the weekend, so I assume that's why things are a bit dodgy at the moment. But yeah, that app is fantastic. You know, like I said, it's ticking all the boxes for me, and I think that's going to be extremely important into our Pi ecosystem. So keep an eye on that. You know, if I get any updates, obviously I'll let people know. But yeah, great application. So that's it for the video. I hope you're all enjoying yourselves. I hope you enjoyed the video, and I'll catch you later.